This is Mr. Ashton going through the Mathematics Unit 1 non-calculator higher tier paper from the autumn-November 2018 exams, okay? I've already done like the first 9 questions on the intermediate paper. It's the last 9 questions of the intermediate paper, the first 9 questions here. So I'm going to skip straight to question 10. If you want to access any of those questions, look at the description below. There's a link to the video, so you can go to that and just fast forward through to the last 9 questions of the intermediate paper. Okay, so the first question then says, describe fully the single transformation which maps triangle A onto triangle B. Okay, now, when we're talking transformations, there's 4 transformations. Number 1, translation. Number 2, an enlargement. Number 3, reflection. And number 4, a rotation. Okay, so what you need to do is look at these and try and work out which one of these are. Now, a translation is literally like me picking up that triangle A and moving it and placing it in exactly the same position somewhere else on that grid. It's clearly not that because it's a different size. Which then brings me to number 2. Enlargement. Has it got any bigger? Yes, it's got bigger. Okay. Has it been reflected? Does it look like it's looking back at itself? No, it doesn't look like it's looking back at itself to me. If I folded it over a line, I don't think it would fit anywhere, so it's not a reflection. And rotation, has it been spun around? Well, you'd look at this and say, yes, it has been spun around. Now, the reason why it's not a rotation, I can put a line through rotation and then I can put an X next to it, is because it's got to a different size. Even though it looks like it's been rotated, this is an enlargement, okay? And the reason why it's page 11, question 10 of a higher paper is because it's not as easy as normal ones. What you need to do is find equivalent vertices to it. So, for instance, you see where the right angle is here. Where's the right angle here? Match them up, you get a ruler, and you join those two up with that ruler. We're now going to look for another corresponding side. So I'm looking for this angle there and there. Again, join them up with a ruler. There. And we can start to see that these lines are crossing at a point. And finally, if I do this point here and here, they cross at the same point here again. Okay? Now, the most important thing that we get from here now is to work out which one. Sorry, I had a bit of a freeze, so let me just repeat myself. Now, the most important thing that we're going to do here is look to see what it says in the question. It says, which single transformation maps triangle A, so this one, to get to this one, okay? Now, I know it's an enlargement. I'll get 1 mark for writing an enlargement. I know where its centre is because I've just gone and found it. So centre is equal to 4, 6. Make sure you don't put your coordinates around the wrong way after doing all that hard work. The next thing you need to do is work out the scale factor. Now, ordinarily, the scale factor, I'd say, right, how do I get from here to the nearest point? So I've gone across 2, down 1. Now, if it was a scale factor 2, I'd go across 4, down 2, okay? However, I haven't. I've gone completely in the opposite direction. I've gone across 1, 2, 3, 4, and up 2. So that has got twice as big, but in the opposite direction. So the scale factor would be -2. 2 because it's got twice as big. So instead of going 2, 1, it's gone 4, 2. And minus because it's gone in the opposite direction. Okay, so they were what you needed to have for the 3 marks there. You just have that, that, and that. Okay, next question is shading regions. There will always be a couple of nice, easy ones we can draw. First one is nice and easy. Does what it says on the tin. X is greater than or equal to -1. Now, you ignore the inequality to begin with. We're just looking for X equals -1. So find X, find where it's equal to -1, and draw a line that goes through that point. Okay? Now, because I'm interested in the region that is greater than or equal to that line, I'm going to draw an arrow here so I know for when I'm doing the next parts which side I'm going to be looking at that line. Effectively, I don't want anything this side, but I'm not going to shade it in just yet. The next graph that is easy is y equals x. Again, ignore the inequality. Y is equal to x, so that's going to be 1, 1, 2, 2, 3, 3, and so on. I've got 3 points there drawn. Now I'm just going to Get my ruler, go through all of those and draw that diagonal line. Okay, now in terms of this bit here, it says y is greater than or equal to x. Go and pick a set of coordinates. Now I usually tend to use the origin, so 0, 0, but it's on there. So I'm just going to choose this point here. Okay, now this point here is 3 for x and 1 for y. So 1 is greater than or equal to 3. Is that statement true that I just wrote? That's this point here. That's not true. So I'm not interested in this side of the line. I must be interested in the other side of the line, so I'm going to draw an arrow pointing up. So it's somewhere in between these two bits so far. Okay? Final thing to do is to go and draw this line here. Now, as I've said, you totally ignore the inequality for now. We're going to treat it as equals. And the reason why this is a hard question is because it's not in the form y equals mx plus c. So what I'm going to do is take the plus 2 over to the other side and get minus 2x plus 1. I'm now going to draw an xy table. So x here. Y is equal to minus 2 times by x plus 1. The values I'm going to choose, 0, 1, and 2. Okay, if needs be, I'll go and choose different values if I can't plot them, but usually these ones work. What's minus 2 times nothing? Nothing. Nothing plus 1 is 1. What's minus 2 times 1? Minus 2. Plus 1, minus 1. And then what is minus 2 doubled? Minus 2 times 2, minus 4, plus 1, minus 3. Can I plot those coordinates? So we've got 0, 1 there, 1 minus 1 there, and 2 minus 3. Yes, I can plot all of those points. So what I'm going to do now is get my ruler through all three. As long as it fits through all three, I've plotted them accurately. Yes, that's fine. Okay. So now I've got to identify the region, so I've got to go and stick something into that inequality. So let me go and write down y is less than or equal to, so now I'm interested in inequality, now I've drawn the line. I've written the wrong thing there. Y plus 2x is less than or equal to 1. Okay, I'm going to choose the same set of coordinates again, because I've already marked it, and see if that fits. So here, x is equal to 3. And y is equal to 1. So 1 will go in there, plus 2 times 3, so 6, is less than or equal to 1. So is 1 plus 1 plus 6 is 7. Is that less than or equal to 1? No, it's not. So again, I'm not interested in this side of the line. So I want this side of the line. Now, where is everything? This side of the line, but above this line and over here, it's this bit here, it's this triangle. Now, truth be told, don't worry too much about the inequalities. That's what people find the hardest about this bit. We've got a triangle here. If we've got 3 lines, I'm going to be making a triangle of sorts, okay? If it's 4 lines, it's going to make a 4-sided shape of sorts. And to make sure that I've displayed my region really clearly, I'm going to put in R there, but what you could do is you could shade in the triangle. What some teachers do is they shade the region that's not there, and it leaves just this lovely triangle there, but I'm just going to put there R for region. I think that I have clearly indicated the region that way. Okay. Okay, so next question says, Katrin is measuring the force between the pair of magnets in a physics lab. It is known that the force F between the magnets is inversely proportional to the square of the distance d. Now, there's some key words there that has basically told me a formula that I need to write, okay? F is inversely proportional, so that's k divided by the square of distance, d, so d squared, okay? That's what that pink line tells me here mathematically. Now I want to go and sub in some numbers here. It tells me that the force F and the distance is 10. So what I do now is substitute here those numbers in. So 4 equals k over 10 squared. 10 squared is 100. Divided by 10 squared to bring over to the other side would be 4 times by 100 to get k is equal to 400. you must come back to this original statement in here and put in your value of k to go in there, okay? Most commonly drop mark for not doing that. F equals 400 divided by d squared. Now, it says, what is the distance between them? Is 100 newtons. So I'm going to put in 100 in there. Is equal to 400 over d squared. Now, I don't like this idea of the d squared, which I'm trying to look for being on the bottom. I'll bring it around here to times by the hundreds, and at the same time then, if I'm timesing by 100, bring it round to the side to divide by 100. Effectively, they just switch places, okay? But make sure that you're happy with why they do that. Don't just learn that as a trick to switch the two. It does work in this case, but not every case. Divide top and bottom by 100 leaves me 4 divided by 1, so d would be the square root of 4, so d is equal to 2 meters. Number 13, we've got a rearranging the formula question. Let me just check that you can see. Okay, so we need to make C the subject. That means we want to get C by itself. At the moment, there's 2 C's that I can see there. Okay, so what I need to do is get rid of the C being on the denominator. Even though they're both on the same side, we want to just have one C by itself, not on the top and on the bottom. So what we're going to do is bring the denominator around here, but remember there's 2 things here, so I'll bring both of them round to the other side. So that'll equal G bracket, so we're timesing by C plus 2. Easy mark then, expand the bracket. G times by C is GC, G times by plus 2 is plus 2G. Because we're making C the subject, to get C's on one side, everything else on the other. So what I'm going to do is get rid of that minus 3D, and I'm going to get rid of the GC here. So I'm going to get 6C minus GC, taking it away. And then I'm going to get 2G, getting rid of minus 3D, plus 3D. Okay? Next thing I'm going to do, now I've got C in both of those things, I'll take C out as a factor to get C bracket 6 minus G equals 2G plus 3D. And then I'm going to divide by that bracket, which is currently timesing by the C. Leave the bracket round there if I want, but there's no need to leave that bracket there, okay? I'm going to not put it in there because I think it looks a bit messy. Okay. Next question. Make sure we have a quick read of the information so I can see for once they haven't actually put it into the diagram. We're told that AO, so A to O, is 30. So that is effectively the radius. So I'm going to write that in, 30 centimetres. And AOB is 20. So A to O to B, that's 20. Now these two sectors are opposite each other. That means the angles opposite each other. So that's also 20 there. Okay. We're then told a second circle has an area which equals the total shaded area above. Calculate the radius of the second circle. Well, what we need to do is work out what that shaded area above is. Now, although they're opposite each other, there's no need for them to. We know what the total angle is there. So because we're working with area of a circle, we're told that the second circle has an area which equals the total shaded area above, is I need to work out what that total shaded area is. So that is my degrees out of 360, because that's what's in a total circle, times by pi r squared. So times by pi brackets 30 squared. Okay, that's the shaded area so far. I'm going to have to do some work out here. I'm going to have to try and do some clever cancelling down as well, because this is non-calculator. So I'm going to divide top and bottom by 10. 4 out of 36 are the same as 1 out of 9, times by, now I'm going to get this number at the front after I've squared it. So 30 squared is 900, and it would be 900 pi. So I've just literally shifted the number to the front. 1/9 of 900 pi is equal to 100 pi. And this is the shaded area. So I'll just point to that. If it was an OCW question, I'd have to say what it is, but I'm just telling you what that is. So this is the shaded area. We're then told, or then asked, to calculate the radius of the second circle. And the second circle has an area which equals that. So my formula for a circle is pi r squared, and that's equal to the area. Now we know that that area must be that because they're equal. Okay, so what I want to do now is do pi r squared equals 100 pi. I'm going to divide both sides by pi to get r squared equals 100. And then I'm going to square root the 100 to find that the radius of that new circle must be 10 centimeters. Okay? Next question is much easier than that as far as I'm concerned. These are quite bog standard and quite straightforward. All you have to do is learn a technique of doing it. Now, my technique is to leave a couple of lines and write out what that decimal really is. So I'm going to say 0.3777 blah, 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 without the recurring dots. Okay? Now, we're going to now, what I'm going to do is, because there's one dot, is I'm going to times that by 10. If it was 2 dots, I'd times by 100. If it was 3 dots, I'd times by 1,000. But it's 1 dot, so I'm going to times by 10. But what I'll do is I'll write this above that, and I will line up the equals and the decimal before I do anything. X times by 10 is 10x. 0.377777 times by 10 will shift everything across one place. So it becomes 3.77777. When I take those away from each other, I'm going to line up the decimal and the equals. 7 take away 7, cancels, 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 stop. 7 take away 3 is 4. 3 take away nothing is 3. 10x take away x, careful here, is 9x. People commonly write 10 there. And then to write it as a fraction, I'm going to divide by the 9. But the problem is that is not a fraction because it has a decimal in it. So what I need to do is times that by 10 to get 34, times that by 10 to make it equivalent, 34 over 90. At no point did it ask me to write it in simplest form, so there's no need to cancel that down. Next question. Now, there's an easy way and a hard way to do these. So I think sometimes you can overcomplicate ones like this. You should know. Sorry, the video froze for a second, so I'm just going to repeat myself. It's all I was saying was that there's an easy way and a hard way to solve these. Now, you should know how to simplify any surds by looking for square numbers in there. So if I write out the square numbers, we could say 1 squared, but it's irrelevant really. 1, 4, 9, 16, 25, 36, 49, 64, 81, and so on. Always a good idea to have those written down when you're working in surds. Can you see any of those numbers that go into the bigger one? Now, I know that 2 isn't a square number. There's no number apart from 1. We never use 1 because it's just going to keep us in the same place. I can see there that 4 goes into the 8. Okay, so what I'm going to do is I'm going to simplify that as root 8 is equal to root 4 times 2. So root 8 is equal to root 4 times by root 2. So root 8 is equal to 2 root 2. That makes this question a million times easier because now I've got 2 root 2 take away root 2 squared. Well, think of it like this. 2x take away x. My answer would be x, wouldn't it? So in this case, it's just going to be root 2 squared. Root 2 squared cancels out to give me just 2. Okay, there's another way that you can do it by doing FOIL, but I think that would, by writing it twice and expanding it out, but I think that way is much easier. Now, just like I did before, here, have a look to see if there's any square numbers that goes into that. And I can see again, actually, I'll use the yellow highlighter again, 4 goes into 20. So, actually, I don't know if I'm going the right way around this. I can probably make this slightly easier by just expanding it out first and then just being aware that a square number is going to go into that eventually. So root 6 times by root 20 is the same as saying root 6 times by 20 like that. Sorry, the video froze again, so I'm just going to reiterate what I said. So root 6 times root 20 individually is the same as just times them all together there. And then that's going to be over root 3. That is then the equivalent to root 120 over root 3, which is the equivalent to the square root of 120 over 3, which is the equivalent of root 40. Okay. Now, as I said before, we already know that 4 is going to go in there. Now, is that the biggest square number that goes into 40? 9 doesn't, 16 doesn't, 25 doesn't. No, that is the biggest square one. So I'm going to then say that's 4 times 10. Again, very easy way to check that you haven't missed it. Is there a square number that goes in 10? No. And then what's the square root of 4? 2. So it would be 2 root 10, which is what I just wrote down there. Okay, over the page. Okay, so over the page, we've got evaluate 16 to the power of minus 3 over 2. Now that minus there, that means something, okay? The minus just means it's 1 over 16 to the power of 3 over 2. Okay, that's what that means. Now, in terms of working that out next, it's 1 over, the denominator is the key thing, is because it's over 2, that tells me to square root 16, and once I've worked that out, I put it to the numerator, so I cube it. The square root of 16 is 4, so it's 1 over 4 cubed, and finally 4 cubed is 64, so it's 1 over 64. The next question says, simplify the following expression. Now, we've got a quadratic up on the top, and we've got a just a normal sort of linear expression to factorise here. The first thing I'm going to do is factorise 4x squared minus 7x minus 2. Now, the way that I do that is I get the first term and the last term, and I times them together. So they times together to give me minus 8. I then look at the middle term, which is minus 7. My numbers must add up to that. I'm looking for a pair of numbers that times together to give me a minus 8, and they add up to give me minus 7. Now, if they times together to give me a minus, one sign must be positive and one sign must be negative. A pair of numbers that times together to give me 8 could be 4 and 2. Now, 4 take away 2 would give me 2. That's not my pair because I wanted minus 7. So again, it's got to be one of each sign. Another pair of numbers times together to give me 8 is 1 and 8. 1 take away 8 is minus 7. That's my pair. Now, the way I factorise this is I drop just the square term there, and I put it in the front of each bracket. Okay? One of my pair of numbers, so plus 1, is going in one of the brackets, and minus 8 is going in the other brackets. Now, if you use this method, you must cancel down where you can, because if I expanded that out, 4x times 4x does not give me 4x squared, it gives me 16x squared. So one of those will cancel down. This one has nothing that goes into both, but this one can be divided by 4 in each place. Okay, now if I expanded that, 4 times x gives me 4x squared, 4x times by minus 2 gives me minus 8x, plus x would give me minus 7x, and plus 1 times minus 2 would give me minus 2. So what I'm going to do now is rewrite this as brackets 4x plus 1, brackets x minus 2, all over, and I'm going to factorise that to being 4x minus 2 by just factorising the linear bit. And I can see that I can divide top and bottom by x minus 2 to get 4x plus 1. Now there's nothing times it, I can leave it out of the bracket, divided by 4. Okay, the next question says, a box contains four red balls, 5 yellow balls, and 1 green ball. 2 balls are chosen at random without replacement. We're on page 18, we're very close to the end. It was bound to be a without replacement question. Find the probability of choosing 1 red and 1 green ball. Now, rather than doing trees, I haven't got a huge amount of space. They've given me a very set way or set criteria of things to look at. Probability of choosing a red and a green, I could go a red, then a green. So work that out. What other ways could I work that out? Well, I could have got a green, then a red. It doesn't say I have to get red, then green. It just says getting 1 red ball and 1 green ball. That happens in 2 places. The chance of me getting a red is 4 out of 4, 5, so 9, 10. So 4 out of 10 times by, and then the green ball is 1 out of 9. Okay, that will give me 4 out of 90. If I went the other way, it would be 1 out of 10 times by 4 out of 9, which is also 4 out of 90. Effectively, just working the other way, because it's exactly the same sort of thing that I'm looking for, it's just going to double that initial probability. So then if I add together those two, or if I do 2 times by 4 out of 90, I get the same answer, which would be 8 out of 90. The next question says, find the probability that they will not, find the probability that the 2 balls chosen will not be the same colour. Now, for them to not be the same colour, there's lots and lots of different ways to do it. So what I'm going to do is try and be really smart and work out the ways that it can happen. So the ways that they will not be the same colour could obviously be a red and a yellow, or a red and a green, or a yellow and a green. So I don't want to try and work out lots and lots of different things. I'm going to look at the probability that they are the same colour, and then I'm going to take that away from 1, and that will give me the probability that they're different colours. Okay, so the ways that I can get the same colour is if I get a yellow, then a yellow. Okay, to get a yellow, we've got a 5 in 10 chance of getting it. Then, because I haven't replaced it, they both decrease by 1. So that would give me a 20 out of 90 chance. I could have also got a red and a red, which would be a 4 out of 10 chance times by a 3 out of 9 chance. Should be 12 out of 90. It's less likely for that to happen because there's less red balls. Now, I can't do a P, a green, then a green, because I'd have 1 out of 10. Sorry, so you can see what I'm writing, times by 0 out of 9, which is 0. There's no chance of it happening because there is only 1 green ball there. Okay? If I now work out the probability of getting the same colour, so P, same colour, that would be 20 out of 90 plus 12 out of 90, which is equal to 32 out of 90, to work out that they're different colours. So P, diff colour, that would be 1 take away 32 out of 90. This is effectively 90 out of 90. So we're just looking to do 90 take away 32. So 90 take away 30 would be 60. Take away the 2 is 58 out of 90. Okay, 58 out of 90. Final question on this paper. Just looking at your transformations. So it's looking at your transformations of graphs. It says the graph shows the sketch of the curve y equals x squared plus 2. The lowest point of the graph has the coordinates 0, 2. Okay, so the key bit is in here. Then it says on the same axis, sketch the graph or sketch the curve of the equation x minus 4 squared plus 2. Okay, now this was what we had originally. So it has altered. Now this plus 2 bit here is the easiest bit. It means the graph is going to move up. Oh, hang on. No, they're the same in both. So ordinarily, if it was just x squared, the plus 2 would mean it's going to move up 2, but it's already had that happen. Now that's there already, so I'm just going to tick that because it's in both. The x squaredness, the squared bit is in both, and then that x minus 4, that's the only bit that's changed. Okay, so in terms of what that means is we move the opposite direction to you'd expect if it's inside a bracket. So rather than taking away 4 from it, we're going to add 4. We're going to go across 4 places here. So pencil, about 4 places there. Obviously, there's no numbers on that graph, so you have to go and label what those coordinates are. Still be 2, it's still up 2 from that bit. And I've gone across 4 places, and that graph should look identical now, okay? So in terms of what I think it'll look like, something like that, okay? Okay, if that video was useful, please can you hit the subscribe button to then make sure that you get access to any more videos that I release. Thank you very much. I hope that was useful.